Hi, welcome to Social Research Insights. My name is Kamakshay Musnuru. I am Principal Consultant at Social Research Insights. The Social Research Insights is not a business organization, it is just a freelance training outfit. We are just a couple of individuals who are into providing training for data science, analytics and IoT. This is in fact one of my video demonstrations which belongs to a series of presentations that related to data analytics through Python or Python programming for business analytics or data science analytics, something like that. In my previous video I explained how to plot the family of T distributions. We call family of T distributions because the shape of the T distribution tend to differ based on the a particular parameter called degrees of freedom. So I've shown you how to plot two different T distributions using two different degrees of freedom. In the same video I've said that I'm going to show you how to highlight a particular part of the area under normal curve. To do all these analytics, there is one important prerequisite for that is Python. So you just have to go to the terminal, you execute Control Alt T. I'm using Ubuntu Linux version 16.04, which is a beautiful operating system, especially for data science, analytics and IoT. There is huge if somebody is interested to build their career in this particular domain of operations, that is data science, it's better to use Linux operating system, and I use Ubuntu because I am very much familiar with Ubuntu. So after you go to the terminal, you just have to type Python --version. Then your operating system your terminal should be able to return some message, and it is very intuitive. You can see that I have Python installed in my operating system, and you need to ensure that the Python is there. But you don't need to worry if you really if you are really interested in this video. By now I think you must be ready with your Python, or if you are using any Linux distribution, the default programming language is Python. So okay, I just close, and now what I do, in my previous video I used a peculiar IDE known as Spider, and in this video I'm going to use another IDE. And as you press the Windows button, like the left bottom corner, the keyboards will be having the little Windows icon, so you need to press that button to open the dash in Ubuntu, and there you just have to press IDLE. Then you will get the IDLE, and you just have to press on that. I'm going to choose 2.7. This is what is the IDLE. IDLE stands for Integrated Development and Learning Environment. It is not just IDE, it is a learning environment. So if you are a learner, you can simply. Now let us go to the actual work that we are going to plot we are going to highlight a particular region of area under normal curve. I think you must be having some sufficient idea about what is a normal distribution, something like that. My approach is going to be like this. First I'm going to simulate the data sets, or you can, if you already have the data sets in your system, you can just import them by using the pandas or maybe CSV module or any other module which supports the format of the data set that you have in your computer. But since this is a demonstration and it is not always possible for us to get real-time data sets, so I'm just going to simulate my own data set, and the steps are going to be like this. Step number 1, I simulate a data variable which is a linear sequence of numbers. In short, I can say number series ranging from -4 to 4, and I will request some number of data points. For that we have a beautiful package as well as the modules and functions in Python. And after that what I do, I convert that actual data variable into the normal distribution by using probability distribution function. We need to have a couple of packages before we get into the action, and I'm going to tell you what are the packages. We need import matplotlib lib.pyplot as plt. What I'm trying to do, I need a package matplotlib, and I need a module pyplot from the package matplotlib, and I'm creating an instance of the same by using an alias name plt. So we need not type the entire statement. Whenever we use the pyplot, we just have to type plt. That is sufficient. We need one more package, that is the import numpy as np. So what I'm trying to do, I'm requesting Python to make numpy package available for me with the name np. We need one more. I think it is better to import scipy. From scipy import stats. That is good. From scipy import stats. I think in stats we have stats norm. I think we have a function. Yeah, these are the three important packages we need to use for the present demonstration. So now I'm going to start my numerical simulations. I'm going to create x is equal to, in numpy we have a beautiful function called linspace. You can just, my IntelliSense starts now. You can see the command here, linspace. You just have to press tab here, and then I request a linear number series starting from -4 to 4, and I want 100 data points. And now if you want to go back and check whether you need not go back, actually you can check right from here. If you want to see the very first few elements like 1 to 6 of x, you can just press or execute a command x square bracket 1 colon 6, something like that. This is what is called the head of the data variable. And if you want to see the tail of the data variable, minus 100, I think this is minus 94. I think this is so this is how you can see the or verify the underlying actual distribution. So we just have to imagine that this is the original data or the observed data, and now we need to make some transformation to get exactly looking bell-shaped normal curve. We should transform these actual observations into the respective densities. For that we have a wonderful function called stats. Let me check. Norm. Yeah, we have norm.pdf. Yeah, okay, x. Then we need to supply some parameters, that is for what mean and standard deviation you are trying the transformation. I just supplied 0,1, which means I exactly expecting to see a precise bell-shaped normal curve. Then press, you'll get all the values. But what I do, I save that object, all the data points in a particular data variable. I call it as y because I already chosen x for, so that it makes some intuitive sense. When I'm finally plotting, I'll be having x comma y as the x and y axis. And now save it. You can follow the same strategy. Y1 colon 6 gives you the very first 6 data points in the densities, the data variable in which we save the densities of the respective original observations. Now plotting is very simple. You just have to plt. We already created an instance of the pyplot as plt plot, then press tab, x comma y. That's it. You don't need to do anything. So I think this is far easier to create a graph compared to Excel, Calc, maybe SPSS. We don't need to if you want to create the same normal curve in SPSS, you need to struggle for not less than 15 to 20 minutes. I may not be true, but it is. I'm sorry, the SPSS community should forgive me. Plot show. Then we are requesting the Python to show the plot. That is the normal distribution. You see, we just used a couple of statements to get a beautiful normal curve in Python, unlike in Excel, SPSS and all everything. Now what I'm going to do, I'll just highlight the area for P of x less than or equal to 0.25. So it goes like this. I think if you have some idea on the probabilities of the normal distribution, normally we try to compute the probabilities. We have a particular tradition, like what is the probability of x is being less than or equal to 0.25, which means I am indirectly asking, I'm trying to find the probability of x getting observed less than or equal to 0.25% of the area under the normal curve. Just like when we have the normal curve, then the probability of observing any area below 50% of the curve is 0.5. Why? Because the exact center of the normal distribution is 0, and the scale varies as 1 to 3 right, minus 1 to minus 3 left. This is the actually standard deviation. This is the expected value for the mean of the mu of the normal distribution. So what is the probability of observing a particular data point, which is xi, x1, x2, x3, x4, something like that. Let's say xi. What is the probability of some xi observing less than or equal to, below 50% of the curve, which means here 0.05. So if I substitute 0.05, then I'll be asking a question: what is the probability of observing a particular data point which is less than or equal to a portion of the area under the curve? So in the same fashion, I'm asking a question. If I ask what is the probability of getting a data point less than or equal to 0.5, which means I am estimating an element, the probability for an element being observed below or left to the mu of the normal distribution. So you can just go through online resources and understand what exactly is the normal distribution. In this particular demonstration, I'm going to explain you how to shade an area. Suppose we already found that the probability of observing a particular data point is less than or equal to what is the probability of getting a data point below 25% of the normal curve, which means 25% means 0.25. So this is the strategy for shading the area below the normality curve. I think it is clear for you. And let's go. I need to cancel this graph device, then go back. To highlight the area, we need to have a particular strategy. That is, since I said that I'm going to highlight the area below 25% of the total area under the curve, for that what I need to do, I need to earmark that particular portion of the data and create a separate embossing. I need to emboss that area on the actual curve. So what I am going to do, I create a separate shade data. This is the data for the x 1 to 25. So I took only 25% of the, because I have 100 elements, the data points in my actual data. So 25 elements will make 25% of the data. And now shade area is going to be same stats norm PDF. We are transforming this x1 to 25. I can simply say shade data. Then I have to give same mu and standard deviation. So we got the data ready for the shade. Now go for the PLT, plot my actual data x comma y, and then after I execute this, the Python will not plot the graph. It is just creating the device ready for the plotting. Okay, everything happens behind the editor. Now I need to shade the area. PLT fill between. That's all, very simple. Fill between. What is the data? Shade data. I think data. Now shade area, which is the densities for that particular part of the data. And I think you can also, okay, let's press OK. Now PLT show. That's all. You see, we got the area which is highlighted for the statement probability that xi is less than or equal to 0.25. And now you can also tinker this graph by adding your own custom color. You can just go back to the fill between statement and say color is equal to light blue. I don't know light whether it is correct or not. PLT show. Yeah, I think we have, yeah, only that particular part of the, because we changed only the shade area, so we did not go back to. So if you want to get the entire, we have to go back and execute the entire command. Plot xy, then shade area light blue, then PLT show. Yeah, I think you'll get the light blue. And you can also change the color as per your, I mean, this is how we produce the graphs for the reports, because doing data analysis is not that great, but we always perform some statistical analysis or data analysis to update them as the form of reports, which makes some sense for the parties. The party can be anything, like anybody, whoever part of your project. Now go back and I'll make it red this time. We have to go to the red, then PLT show. Yeah, so you'll get the red color. Now you can save by just pressing on this little floppy icon and go to your any drive, and there you can, I mean, you can go to any directory or folder. There you can save it. After that you can think as how to carry ahead this reports. And you can also update some text in this graph. Suppose you want to make I want to put some text in the PLT annotate. I think yeah, P x less than or equal to 0.25, and we need to choose a particular portion of the, so yeah, first let me go to the, yeah, plot is not there. Let me again press the, okay, we got it. So let us choose the, we are going to highlight this particular area. I'll see that my text will be somewhere here, and I'll have an arrow. So I'll choose 0 and 0.10 for text, and from there I point the arrow to 2 and 0.05. so we need to note it down. 0.15 for text, and I say minus 2.10 for arrow. So for that, what we need to do, press all of them. You have to go for the PLT annotate, then for the area under 25%, the area under 25% of the curve, then xy is equal to this is not for the text, so minus 2 comma 0.10, then xy text is equal to I think 0.15 1 5. Then arrow props, props is equal to dict. We have to provide dictionary. The arguments need to be provided in the form of the dictionary dict. We have to give an argument called face color is equal to black. Then shrink, another parameter. This can be the value for shrink can be something like say 0.1, and width of the arrow is going to be 2. Head width is going to be 4. Then color of text is going to be red, something like that. So we are not going to do anything. We have to do this along with plot xy. Where do I have that plot xy? Yeah, plot xy. Then plot the area, fill between. We have to go to the yes. Now annotate. Yes. Now plot show. Yeah, I think we were not able to plot the curve because we did a small mistake in our annotate statement. That is point, instead of putting 0.10, I had comma here, so that was a mistake actually. Anyway, that is not a big thing, and I just have to go through each and every statement so that, but fine, that's, we learn by doing mistakes, and I always happy to do the mistakes. I'm a man of mistakes. I always admit that I'm a man of mistakes, because we can't learn anything without doing mistakes. So next time I will not do this mistake. So after I mend it, I think it is very clear for you. Plot annotate, you have to put something, some statement here. You can also keep some so I think better to put p of x less than or equal to 0.25. That makes more sense because it sounds a bit technical. Now I think I have to press OK. Now let's go back and make everything in sequence. Plot xy, plot fill, yeah, and then annotate, and then plot show. Yes, see, beautiful. But there is one simple mistake, that is we have chosen -2 and 0.10 for head. So what we try to do, we'll push this arrow down, little down. So this time what I do, -2 and -0.5. So that makes sense. I'll change the statement, annotate statement, -2 -0.5. That will do better. -0.5. Okay, now show nothing. So we have to go everything in sequence. Plot xy, plot fill, and then annotate, and then plot show. Yes, this time I think it looks a bit more. You can also think of shifting this text a little to the center of the curve. Okay, anyway, that is sufficient, and this is how we can plot the normal distribution and highlight the area for a given probability or probabilities. And then you can just press this little floppy symbol to save this graph somewhere in your computer, and then you can import this graph and embed this graph in your respective reports. So please be mindful that we do statistical analysis or data analysis to make some reports. If the reports goes to a paper file, then it is called data analysis or data analytics, and the paper goes to the web browser, then we call it as a data science. That is the essential difference between the data science and data analytics. Thanks for watching this video. If you like my video, please press like. Kindly don't press unlike or dislike. Stay tuned for the new content. Subscribe to my video channel. Thanks for watching.